In this video, we're going to focus on a brief overview of compounds. So this is our little classification of matter chart. We're zooming into the pure substances section. As you know, pure substances can be elements or they can be compounds. So basically when you combine elements, different elements together with bonds, so using those valence electrons to connect different elements, you get compounds. And compounds will fall under two general categories, and we are going to explore those compounds in this lesson today. So our formal definition of compound is two or more different elements. So it has to be different elements. It can't be two of the same elements. Two or more different elements connected together by a chemical bond. So a bond is basically an attraction or a link between the two different elements. And the chemical bond is formed by those valence electrons we've been talking about so much. Valence electrons, because they are the outermost electrons, so they're most accessible. So when we look at compounds, there's actually two types. There are ionic compounds and molecular compounds. They're also called covalent compounds. So molecular or covalent and ionic. Ionic compounds have to have a metal in it, and the other element in it's a non-metal. So basically, metal and non-metal make an ionic compound. So as soon as you see a metal, typically you're going to see an ionic compound. There are some exceptions to that. We're going to see different types of ionic compounds later on, but metal, non-metal make ionic compounds, and they're formed by transfer of electrons, electron transfers. So we're going to take a look at the picture below to show you what I mean by that. In this picture, we have the formation of salt. Sodium, you'll notice, is losing an electron to chlorine. So chlorine is receiving an electron from sodium. That's a transfer of electrons. When that happens, sodium becomes positive, right, because it lost an electron. And chlorine becomes negative because it gained an electron. So now that they have opposite charges, positive, negative, they attract each other because opposites attract. This attraction due to opposite charges, that's the ionic bond. So an ionic compound is made up of a metal and a non-metal. For example, here we have NaCl. The metal is Na, Cl is the non-metal. It's formed by a transfer of electrons. So usually the metal is going to give up or lose its electron, its valence electrons, to the non-metal, and they become ions, they become charged. When they become charged, they are attracted to each other, and that's really the bond, that attraction between the opposite charges, and that's called the ionic bond in an ionic compound. Now, the other type of compound we talked about is the molecular compound, also the covalent compound. This is where you have two or more different non-metals. There's no metals in this, just non-metals. So hydrogen's a non-metal, oxygen's a non-metal. Rather than formed by transfer, these compounds are formed by sharing of valence electrons. Sharing. So there's actually no ions formed here. For an ion to form, electrons have to leave. They have to be taken away or received. So chlorine becomes chloride because it received an electron. Sodium became sodium positive because it lost an electron. In molecular or covalent compounds, there's no gain or loss. They're simply sharing. So here we have the formation of water. You have two hydrogens coming together with an oxygen to form water. And you'll notice that the electrons were not transferred, rather they're sharing over here. So the oxygen had an electron over here, the hydrogen had an electron here, and they decided to combine these two to make it as if they have one new one each. Same thing over here. So for oxygen, when you count the valence shell, there's 1, 2, 3, 4, 5, 6. This one it's sharing with hydrogen here. 7, 8. So it's as if oxygen has 8 valence electrons. And hydrogen as well. Now it has 2 valence electrons, and we know that's a complete shell for hydrogen because it only has 1 shell. Same thing here. So they decided to pool their collection together to have a complete set, as opposed to just transferring like they did in the ionic compounds. So ionic compounds, metal, non-metal, transfer of electrons, ionic bond holds them together, that attraction of opposite charges. Molecular or covalent compound, two or more different nonmetals connected together. It's a share rather than a transfer of electrons. And the sharing of electrons, that bond, the special name it's given, is called a covalent or molecular bond. So molecular compounds have covalent or molecular bonds, whereas ionic compounds have ionic bonds. So let's take a look at this over here. This H2 is considered a molecule, but it's not considered a compound. Remember our definition of compound: two or more elements, different elements, connected together by a chemical bond. This is certainly two or more elements, but it's not different elements. It's the same element connected to another one of itself. So this is a molecule, but it's a molecular element. So molecular element would really be two or more of the same non-metal connected to itself. Okay? Whereas to actually be considered a molecular compound, you need to have two or more different non-metals connected together. These two are different. So this would be a molecular compound. So the way to think about it is basically a molecule is two or more, I'm going to write 2 plus, two or more non-metals connected together. If they're the same non-metal, then you have a molecular element. If they are different non-metals, then you have a molecular compound, because they have to be different elements. Either way, they're both formed by sharing, and they're both connected together by molecular or covalent bonds. So you need to know some major properties of both types of compounds that we just discussed. You should know the properties of ionic compounds and the properties of covalent or molecular compounds. And you'll notice that quite often they're basically the opposite of each other. Ionic compounds, they have a very high melting point. Melting point is basically just the temperature at which something melts. So for example, to melt salt, NaCl, you have to reach a temperature of 801 degrees Celsius. Whereas covalent compounds have a low melting point. You know that water, a covalent or molecular compound, melts at 0 degrees Celsius. Boiling point, the temperature at which something starts to boil. For ionic compounds, it's a high boiling point. For covalent compounds, it's usually a lower boiling point. In terms of conducting electricity, ionic compounds will conduct electricity when they're dissolved in water, whereas covalent compounds do not. State at room temperature, usually ionic compounds are solid at room temperature. And for molecular or covalent compounds, it differs. Sometimes some are solids, some are liquids, some are a gas at room temperature. In terms of the hardness, ionic compounds are hard and brittle, whereas covalent compounds are usually softer. And in terms of solubility, most ionic compounds dissolve in water. So when you put, let's say, some table salt in water and you stir, it starts to disappear. It's not really disappearing, it's hiding in the water molecule. That's what dissolving really means. So typically ionic compounds will dissolve in water, whereas covalent compounds, some will dissolve, not all, but some do. So when you put sugar in your coffee or your tea, you'll notice that it, well, disappears, or in other words, dissolves. It's hidden within the water molecules of the coffee. So some do dissolve, not all, but some will. There's exceptions to every rule that I mention here, but I need you to know the general characteristics, at least at the grade 10 level. Sucrose is just the name for the sugar that you use at home, the sugar that you find at home in the bag, the table sugar, that is sucrose. Now, another interesting thing about ionic compounds, as I mentioned, is that they conduct electricity. And so you can do a neat experiment to determine if you have an ionic compound or not. So in this experiment, you'll notice that there's this light bulb with these metal leads that are dipped into pure water. So there's nothing dissolved in the water. It's just H2O all the way. And you'll notice that the light bulb is not glowing, and that's because pure water won't conduct electricity. Pure water is a molecular compound. Now let's take a look over here. Here we have an ionic compound. We have some NaCl, and I told you guys that NaCl should conduct electricity, but the light bulb is still not glowing. And just pay close attention to what I said in the previous slide. I said that ionic compounds will conduct electricity when they're dissolved in water. So here we have the salt dissolved in the water, and you'll notice that now the ionic compound, now the salt, is conducting electricity and allows the light bulb to glow. Sometimes you can use this trick to determine if you have a molecular or ionic compound. So let's say I gave you sugar and you didn't know what it was just by looking at it. There's many substances that are white and that could dissolve in water. So I'm going to dissolve sugar in water. You might think that it's ionic because it dissolves, but keep in mind that some covalent compounds do dissolve as well. So what you can do is another test. You can take this light bulb, dunk it into the water. If it doesn't glow, then that means the sugar that you put into the water is considered a molecular compound, because molecular compounds do not conduct electricity. So again, pure water did not conduct electricity, which is why the light bulb did not glow. The ionic compound should conduct electricity, but not in its form, not in its undissolved form, really only in its dissolved form. If molecular compounds do dissolve, you can test whether or not they're molecular by putting the light bulb in, and you'll notice that the light bulb won't glow if it's a molecular compound that was dissolved in the water, because there are no ions. To conduct electricity, you really need to have these charges here, which is what the ions provide, and those ions formed by transfer of electrons, which is what we find in the ionic compounds. Another interesting point that you should focus on for ionic compounds is that they usually have these crystalline structures, crystal structures. So if you zoom into a salt grain, you'll see it looks like a crystal. And if you zoomed into that to take a look at the ions, you notice they form this structure over here called a crystal lattice. It's basically just the arrangement of the ions in an ionic compound. So you'll notice that there's an alternating arrangement here. You have NaCl, 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 because the opposite charges are attracted to each other. Okay. Typically, molecular compounds will not have this crystal structure. It's mostly a defining feature of ionic compounds. So you should be able to use your knowledge of the periodic table to classify elements or compounds as either molecular or ionic by looking at their composition. So if you take a look over here, we have NaCl. We know that Na is a metal, Cl is a nonmetal. So that means that we have an ionic compound over here. And I'll do one more example for you. Let's go take a look at CO2. Well, C is a nonmetal. O is a nonmetal. We have two different nonmetals, which means that CO2 is a molecular or covalent compound. You can apply that same logic to the rest of the examples, and pay close attention to the one I put a question mark on. There's a reason I put a question mark there. Look at the way it's written out, and you'll understand why. So to finish off, I just want to paint a more complete picture of the classification of matter. We were studying pure substances. And as you know, pure substances can be either elements or compounds. So we can have elements or compounds. Elements can be of two types. They can be atomic elements, where you only have one atom of that element. So for example, Na. This is just sodium, one atom of sodium. There's no number written there, so it's an implied one. You could have molecular elements, where it's two or more of the same non-metal. Okay, two or more of the same non-metal. And they're connected together by sharing, in other words, a covalent bond. For example, CO2. Nope, that would be wrong. That would be a compound. Sorry. For example, H2. Two of the same non-metal. O3. Three of the same non-metal. Cl2. Two of the same non-metal. Okay, but they're still sharing electrons, so it's still connected by a covalent or molecular bond. Compounds, they can also be molecular. In order for a molecule to be considered a compound, it has to be two or more different non-metals. For example, CO2, H2O, a whole bunch of them. And you should know that they're connected together by a covalent, or molecular, you could say as well, bond. Same thing with the molecular element. It's a covalent bond. It's a share. Again, that means sharing. Sharing of valence electrons. And you can also have ionic compounds. Which is a metal with a non-metal. For example, NaCl. And rather than share, they form because of a transfer of electrons, and ions form as a result of that, which leads to the attraction between opposite charges. So it's really because of the ionic bond that they're held together. Ionic bond, a bond between ions. So it's a transfer of electrons. You cannot have an ionic bond in molecular compounds because they don't transfer electrons. They don't form ions. They just share. When you share, ions do not form. But when you transfer, lose, and gain electrons, then ions do form, because ions are charged atoms that form due to the loss or gain of electrons. You should be able to compare atomic elements to molecular elements, so find some similarities and differences between them, and provide an example of each. You should be able to compare and contrast molecular elements and molecular compounds, again, finding similarities and differences and providing examples of each. And then try to compare and contrast ionic compounds and molecular compounds, so similarities and differences, and provide an example of each. You should especially focus on the properties of ionic and molecular compounds in terms of how they compare to each other. We're going to proceed for the rest of, in the rest of the unit by taking a look at how to name ionic compounds. We're going to name binary ionic compounds, and then afterwards we're going to name something called ternary ionic compounds. They have those ions that we saw called polyatomic ions in them. We will learn how to draw and form ionic compounds, and afterwards we're going to go and take a look at how to name covalent compounds, make formulas for them, and we'll learn how to draw and form them as well. This will come after. We're going to focus on ionic compounds first, because they do have different sets of rules when it comes to naming them.